Alright guys, I'm back. Trying to make a little more space, so hopefully we can finish it off with one more video. Picking up where we left off, we have a between problem. We want to find the probability that the thermometer reads between negative 2.0 and 1.5. So those are our z-scores. So again, let's sketch it. Your mean is always in the middle, standard normal, so 0 is our mean. We've got two z-scores though this time. One's positive, one's negative, so I'll put them on either side. This is negative 2.00. This is 1.50. Now, you could put like Z1 and Z2 underneath these and just put Z1 and Z2 on here. I've got enough space though, so I'll just write it out. We want to know what the probability for being between these two guys is. So we're trying to look at this inside part. We've got to figure out how to do that. So I have my two z-scores. And as you can guess, with the calculator, it's going to be pretty straightforward. But with the chart, let's look at how we're going to do it with the chart. If z is negative 2.00, what do we get from the chart? Let's find out. So z is negative 2.00, and yeah, we get this number right here, 0.0228. 0.0228. Now let's think about what that means. So if we sketch a curve, and we have the z-score of negative 2.0 right here, that's going to give us this little area to the left. And if we do 1 minus that, that's going to give us the whole area to the right. We actually want the area between. So let's just hold off for a minute and see what happens. So I'm going to go to the chart and get my other number. This time we're going to look up what happens if z is 1.50. That's positive 1.5 and O this time. So that's going to be 0.9332. So here we go. We got these two numbers. So the 0.9332, that's the area to the left of this thing. So yeah, I'm going to go ahead and make a couple more of these so we can play with them. We got this z-score and this z-score here. So here's the negative 2. Right now, we have this area. Let's do 1 minus that number. If I do that, one minus 0.0228 gives us 0.9772. So that's the area on this section. So let's see if we can use that somehow. Okay, I have the area over here and I have the area over there. 1.50, that's over here somewhere. Here's my 0. 1.5 somewhere over here. And this area is everything to the left of it. Well, let's try and find this area over here, and maybe we can combine them somehow. You might already see it. And figure out what that total area is between negative 2 and 1.50. So I'm going to do 1 minus 0.9332 0.332. I'm going to be lazy and use the calculator. That gives me 0.0668. All right, so that actually is this area right here. So we turn this area into that. So if I take everything to the right of -2 and subtract everything from the right of 1.5, then I'll get everything between -2 and 1.5. So in other words, I'm going to take this area to the right. Let me highlight it in blue. And this area to the right. And subtracting them will give me this area in the yellow. It'll give me what's left when I take everything to the right of here minus everything to the right of here. So that's going to be 0.9772. That's this whole area here. Minus the area here is 0.0668. I'm going to take 0.9772 minus the 0.0668. Gives me 0.9104. So that is the area between -2 and 1.5. Calculators, much easier. Same processes to the left or to the right. Just type it in. So lower bound, -2. Upper bound, 1.5. Standard normal, 0, gives us the probability of 0.9104. Same exact thing. For the TI, again, we're going to go to the normal distribution, the normal CDF, and I'm just going to put that in there. Get rid of all this. So it pops up with that for you. We want the lower bound, -2, comma. Upper bound is 1.5. Mean, standard deviation. Same thing. And I'll show you, again, the calculator assumes normal distribution if you don't put anything. So I can just put lower bound and upper bound, and it will assume 0, 1 for the mean and standard deviation. Same thing. Okay, so that's how you do between. We did a right area to the right and area to the left. So between has a little bit of work using the chart. The other two, pretty straightforward. What if we have to go the other way around, though? What if they give us probabilities and we need to find the respective z-scores? So use the same thermometers as before. This is page 289, by the way. Find the temperature corresponding to the 95th percentile. That's 95%. And so if we look at that, it's going to be right here. So we're looking for the probability. Well, it gives us the probability of everything up here being 0.95. We're trying to find out what the z-score is. Again, our mean standard normal distribution is 0. So we're looking for this z-score here. So we're going to go to the chart. 0.95. Well, that's okay. It's important that I knew that the z-score was above 0. What percentage do you think would be at 0? Like if we had exactly half of it. would be 0.5. So if the probability is above 0.5, it's a positive z-score. If it's below 0.5, it's a negative z-score. And if it is 0.5, then it's a 0 for your z-score. So let's look at the positive z-scores. And instead of looking for a certain z-score, we're going to look for a certain probability, 0.95. So I'm going to look in here until I find 0.95. It does increase as we go, so it's going up, 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 up. Then it goes to the next line, up, up, up. So right here, somewhere between here, oh, hey, look, there's an asterisk. Probably it means something. Oh, there we go. For 0.95, since it's a very special number, it's used very often, they go to 3 decimal places on their z-score, 1.645. Typically, we can get by with just 2. But if we look at it, z is going to be 1.645. Now let's see how we do that on the calculators. Casio, again, we're going to go mode 3, but instead of the normal CDF, since we're not looking for a probability, we're given a probability, we're going to do the inverse normal. The area, 0.95. Mean and standard deviation are the same, so 1.6448, 1.645 if you round it. For the TI, second bars again, number 3 is the inverse normal. I'll just put something right in there so I can get this. And just like before, it assumes standard normal if you don't put anything else. If I just do that, it'll give me the right answer. But I can always put in the mean and standard deviation there. 1.6448. So that does round to 1.645. Okay. So that's how we go the other way around to get the z-score from a particular area. Let's try a couple that are non-standard normal distributions. So that means we're going to have mean and standard deviation that are not 0 and 1. So a psychologist is designing an experiment to test the effectiveness of a new training program for airport security screeners. She wants to begin with a homogeneous group of subjects having IQ scores between 85 and 125. Given that IQ scores are normally distributed with a mean of 100 and a standard deviation of 15, what percent of people have IQ scores between 85 and 125? So this is a between problem, and it's going to be 85 and 125 for our z-scores. So again, first thing we want to do is sketch that curve. Let's see what's going on here. So I'm going to move it over here. The mean is not 0. The mean is 100. Now, our z-scores are 125 and 85. And we want between those two values. So if we're using the chart again, it's going to take some work. The first thing we need to do is standardize, normalize these scores, standard normal. So we're going to use that formula on our formula sheet right about here. This formula, z equals this. So I'm going to convert these two scores, the 85 and the 125, to standard normal z-scores. To do that, first one, we take the value, x, subtract the mean, divided by the standard deviation. So you can do that in the calculator. That's going to give you -1. If we do the other one, the 125, I'll do it in red. That one I'm going to need a calculator for. That's going to be 125 minus 100 is 25 over 15 is 1.67. For z-scores, just go 2 decimal places. Z-scores 2 decimal places. Areas 4. Probability 4 decimal places. Z-scores 2. So 1.67 here. Yes, this is a negative. That's a positive. It's below the mean. That's above the mean. Makes sense. So let me get the chart out. Now that they're normalized, standardized, we can find their respective areas. So -1.00 is this number right here, 0.1587. So, you know what I'm going to do? Oops. I'm going to have a frozen screen. There we go. Okay, it's not right there. Well, that worked. I'm going to move this on the right side, that on the left side, so I can have some room to work. And this, I'll just move up a little bit. I'll hide it behind me. So here's our two z-scores. If we remember from the previous between example, what we needed to do was get the complement of each of those and just subtract them. So for -1, we get 0.1587. I do 1 minus that to get its complement. And I get 0.8413. For this guy, it's a positive z-score. It is 1.67. 1.67 is right here, 0.9525. Get its complement, 0.0475. Use the calculator if you want. Subtract those to get our shaded region. So let's see. I'm going to do 0.8413. That's the area to the right of -1 minus 0.0475. That's the area to the right of 1.67. Definitely going to use a calculator on that one. And we get 0.79838. So let me move me for a second. There's our shaded region here. The probability of being between, the probability of someone having an IQ score between 85 and 125 is 79.38%. Again, calculators make it a lot quicker and easier. Starting with the Casio, not needing an inverse normal, we need a normal CDF. Lower bound, this time we're going to just type in 85. Upper bound, 125. Change your standard deviation to your mean. The mean is 100, standard deviation is 15. 15, 100. And it gives us 0.7935. So slightly different there. As we get higher in numbers, it's going to get further away from the chart, because the chart actually does have a lot of rounding involved. So we'll get slightly different answers. So Casio 0.793, well, 55, so 7936. It's just 2/10,000ths off, so it's not that significant. Check the TI, let's see if it's any better. Normal CDF. You know how to type it in, so I'll just use it here. 85, 125. Again, it's mean, the standard deviation for the TIs. This is what you should have. Normal CDF, 85, 125, mean, standard deviation, gives us 0.7936. I will take either answer. Doesn't matter to me how you do it. Let's do one more example before we call it a day. Scores, yes, I know what I said. Scores by women on the SAT are normally distributed with a mean of 998 and a standard deviation of 202. Scores by women on the ACT are normally distributed with a mean of 20.9 and a standard deviation of 4.6. Assume that the two tests use different scales to measure the same aptitude. So basically, they're basically measuring the same thing. If a woman gets a score that is the 67th percentile, find her SAT score and her equivalent ACT score. So we have the percentile, and they're asking us to find the score, the Z-score. So that's an inverse problem. So let's look right here on the, let's draw it out. So we want the 67th percentile. This is for A, by the way. So that's above 50, so I'm going to put it to the right of the mean. Talk about SAT. Notice we have two different things going on, so pay attention to which one it is. The mean is 998. So I'm just going to go ahead and write that information down. We're probably going to need it in a minute anyway. So for the SAT, the mean is 998. Standard deviation is 202. For the ACT, so that's mean and standard deviation right here. For the ACT, mean is 20.9. Standard deviation of 4.6. Okay. So we're talking about the SAT. So that's this guy. Mean is 998. We want 67th percentile. So that's above 50%. So my Z-score is above the mean. Get over here. This is what we're going to look at. So we want to find out the Z-score that corresponds to the 67th percentile, or 0.67. So let's go to standardize this score. Let's look at our formula again. Z is equal to X minus mu over sigma. Okay. So we're looking for the Z-score. We know we actually don't know her X, so we need to find the X. So we're going to rearrange this equation, do a little bit of basic algebra to find X. So that's going to be the corresponding Z-score times sigma, multiply both sides by your denominator, add the mean. Okay, if we do that, that'll give us what X is. So the Z here is going to come from the chart, or inverse norm, So we're going to look up the chart, 0.67, see what it tells us. Now again, we need to be in the positive because it's above 50%. Oh, there we go. 0.6700, can't get much closer than that. If you don't have the exact number, which a lot of times you won't, just go with whichever one is closest to the number you're looking for, or use a calculator. So the Z-score here is 0.44. Let's remember what the Z-score is again. Z-score is how many standard deviations away from the mean your value is. Oh, hey, look. Standard deviations away from the mean times standard deviations plus the mean. That's how we get our X value. That's how we get our actual SAT score, sorry. So we're going to do 0.44 times standard deviation was 202 plus the mean was 998. We get 1,086.88. Doesn't tell us round or anything, but I don't think you can get a decimal on the SAT. So let's go with rounding this thing, 1087. Actually, let me see if this formula is on your formula sheet. Maybe you won't have to solve for it. Nope. So it does give you this formula. Just rearrange it for X to find out what that value is. So X is 1,087. Let's go back and read our question. So her actual SAT score was 1,087. Actually, let me check space. Hopefully we can get through this whole video. Okay, hopefully this will work. SAT score is 1087. Now we need to convert that to her equivalent ACT score. So 1087 was for the SAT. Now for her ACT score, well, it's still the 67th percentile. It doesn't matter if it's on one test or another, it's the same process. So we already know that Z is 0.44. So this time, instead of using the SAT's info, we're going to use the ACT's info. So that's going to be 0.44 times the standard deviation is 4.6 plus the mean is 20.9. That's going to give us our X value. and 22.74, so 23 on the ACT. Let's see how we do it on the calculators. So again, we're going to go to the inverse normal. The area is 0.67. Put in the standard deviation of, for SAT, 202, mean of 998, and we get the 10,087 without any work whatsoever. So calculators are very nice. TI, same thing. 0.67. The mean is 998. 202 for the standard deviation, and again, we get 1087. Type it in the same way for the ACT. Only thing we're changing is the standard deviation and the mean. .9. That's actually a little higher than we got on doing it by hand, I do believe. 22.74. So yeah, still rounds the same thing, 23 on the ACT. But whenever you do these by hand, whenever you do them by calculator, it is very possible to get slightly different answers. Mean, standard deviation, so the mean is 20.9, standard deviation is 4.6, 23. All right, part B, let's just call it a day, guys. All you do for this one is find out what the z-score is for 1220, use that z-score and this formula to find out the ACT score. To make sure that hopefully there's enough space in this video, I'm just going to end it now. And that was the last thing I wanted to go over. So I'm going to upload some more practice problems for you. Feel free to email me with any questions, and I'll talk to you later.